Okay, this video will be dealing with complex numbers. Complex numbers are numbers that can be written in the form of a plus or minus bi. The a portion of the complex number is any number you've ever come across so far. 1, 2, 3, -5, -10, -41, 2/3, 1.5, 7.3, any real number. Pi even is irrational, but it's still a real number. Those numbers are all the a part of a complex number, and we put the real part before the imaginary part. The imaginary part is the part with an I in it. The imaginary part, the I for imaginary. The b is just a coefficient. Again, it would look like any other number. It's the I that makes it imaginary. I equals the square root of -1. Now, many times when dealing with square roots, you would have been told that you can't get the square root of a negative number. If you had been dealing with the square root of -4, for instance, you would have been told that it's no real number, and you would have just stopped right there, and you would have written your answer, no real number. And it's true, that is no real number. There's no number that is the square root of -4, no real number. However, if we think of the square root of -4 as the square root of -1 times the square root of 4, then we can turn the square root of -1 into I, and the square root of 4 into 2, and that would become 2i. This is what happens when you get the square root of a negative number. Either you get something along the lines of square root of -4 equals 2i, or the square root of -3 equals I square root of 3, or the square root of -18 equals I square root of 18, which can be broken down further because there is a square root of 9. So we end up with 3i square root of 2. Either everything can be rooted, like the square root of -4. Nothing can be rooted. All you can do is take out the I, as in the square root of -3. Or some can be rooted, some can't be, as in the square root of -18. Either way, that negative always comes out as an I. Notice all of these are square root, though. I is only for the square root of a negative number. We do not use I for cubed roots, or fourth roots, or fifth roots, or sixth roots, or any other root. I is only used for the square root of a negative. Now, once we have the I out, there's all kinds of things we can do to it. We can add it, 2i plus 3i, and get 5i. We can multiply it and get 2i times 3i equals 6i squared. But when we get a 6i squared, we're going to need to simplify it. We'll talk about that in just a second. We can subtract it, multiply it, divide it, add it. Anything that we can do with a variable, we can do with an I. It's not technically a variable because we know exactly what it refers to, but we can treat it as a variable as we work it. Anything you can do with a variable, you can do with an I. But like I said, if we end up with an exponent on the I, we need to simplify it, and this is how we simplify it. I equals the square root of -1. I squared would equal the square root of -1 squared then. When you square a radical, it just cancels. Just like when you multiply and divide by 3. Those cancel. Adding 3, subtracting 3 cancels. Squaring and square rooting cancel, leaving us with just -1. I cubed would be the same as I squared times I, and would just determine that I squared is the same as -1, so -1 times I would be -I. I to the fourth would be the same as I squared times I squared, which is negative 1 times negative 1, which would be 1. That's our pattern right there. If we do I to the 5th, it's just going to start the whole pattern all over again, because I to the 5th is the same as I to the 4th times I, which would give us 1 times I, which would just be I, starting the whole thing all over again. I simplification has a 4-step cycle. I squared is negative 1, I cubed is negative I, and I to the 4th is 1. Notice we never end up with an exponent on the I. No matter what we start with, we always end with one of these 4 results. I liken it to the Wheel of Fortune with only 4 spots. If a little old lady spins on the Wheel of Fortune, we don't care how far it goes. Click, click. Wherever it stops, it stops. Football player during NFL week, he spins the Wheel of Fortune. It spins, it spins, it spins, it spins. They go to commercial, they come back, it spins, it spins, it spins, and then it finally stops. They look at where did it stop. They don't care about how many times it went around. We don't care how many times we go through this cycle. All we care about is where did it stop. Did it stop with 1 click, 2 clicks, 3 clicks, or 4? After it went around complete times, how many extra clicks did it have? So if we consider I to the 34th, how many times would 34 clicks go all the way around? Well, every 4 clicks is 1 full turn all the way around. So there would be 8 complete revolutions out of 34 clicks. That would have been 32 clicks, leaving us with 2 left over. And I squared would be negative 1. So I to the 34th is the same as I squared, which is negative 1. I to the 23rd, 23 divided by 4 is 5, so that's 5 total complete revolutions. But we care about the remainder, 3. 3 extra clicks after it goes around a complete time means that I to the 23rd is the same as I to the 3rd, which is negative I. I to the 49th, 49 divided by 4 would be 12, but we don't care. All we care about is the remainder of 1, and I to the 1 would just be I. I to the 92nd would have 23 complete revolutions and no extra clicks. So you can think of it as I to the 0, and anything to the 0 power is 1, or you can say, well, it went around 1 full complete revolutions and ended on 1. One way or the other, it's going to be 1. But we always end up with one of those 4 results. We never leave an exponent on an I. So if we had the quadratic equation 4x squared minus 2x plus 3 equals 0, it's not factorable, so we have to use the quadratic formula to solve it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. When we plug in, that gives us negative 2 plus or minus the square root of negative 2 squared minus 4 times 3 all over 2 times 4. Simplifying, that gives us 2 plus or minus the square root of 4 minus 48 all over 8. Doing the subtraction would give us 2 plus or minus the square root of negative 44 over 8. So that negative sign is going to come out as an I. And 44 can be broken down into 4 times 11. And the 4 is a perfect square root. So that can come out, leaving us with 2 plus or minus 2i square root of 11 over 8. And we can factor out the common 2 and cancel the 2 and the 8, leaving us with the 4 in the denominator. Or if you feel more comfortable with it, you could have just canceled the 2's directly without factoring them out first. But make sure you do all or nothing. It's all 3 elements that get factored, or none of them. Or you factor out the commons and just cancel the factors the way I did in purple there. Either way, we should end up with 1 plus or minus I squared of 11 over 4. So that's the I. It's only on the square root of a negative, We pull it out as an I. We work the rest of the number like we normally would. We can add them, subtract them, multiply them, divide them like any variable, even though they're not technically a variable. When we're done doing all that, if an I has an exponent on it, we simplify it into one of the four that I mentioned. I, negative I, it was I, negative 1, negative I, or 1. I squared, I cubed, I fourth. That Wheel of Fortune pattern I told you about. And then we can use it when we're using the quadratic formula, because often we'll end up with a negative determinant telling us there'll be two imaginary solutions. And in this case, it would be 1 plus I squared root of 11 over 4 and 1 minus I squared root of 11 over 4. That's the I.